All right, welcome to the video on coordinate proof. The purpose of this video is to take what you know about writing proofs involving triangles and combine it together with what you know about the slope, distance, and midpoint formulas to write a new kind of proof called a coordinate proof. Now, like I said already, these coordinate proofs will involve our use of the slope, midpoint, and distance formulas because we're going to be working on the coordinate plane. Now, the steps that you'll follow are in that box at the middle of page 3. First thing you're going to do is draw and label a graph so that we have a nice visual idea of exactly what it is that we're working with. The second thing that we're going to do is state any formulas that we'll be using along the way. Of course, you're going to want to make sure that you show all of your work. And then lastly, we're going to have to make sure we have a concluding sentence stating what we've proven and how come it's true. All right, so with that said, let's get into this. In number 1, it wants to know, what does it mean for a triangle to be scalene? So I'm going to ask you to dig back to your middle school years and your knowledge about triangles and their classifications, and think about what it means for a triangle to be scalene. Hopefully you're remembering that in order to be scalene, a triangle has to have all sides of different lengths. Or you might say no two sides are the same. That's what it means in order for a triangle to be scalene. Now, my next question is, which of the formulas above, slope, midpoint, or distance, could be used then to prove that a triangle has all sides of different lengths? Some of you will see this more easily than others, but I hope eventually I can convince everybody that the formula that we want to use is the distance formula. Distance formula measures the length of a line segment, and if we can show that all three sides have different distances, they must therefore have different lengths, making the triangle scalene. If you have questions about that, jot them down in the margin right now and make sure to ask me the next time that you come back to class and we can talk about that a little bit more in depth. In the meantime, I'm going to scoot ahead to number 2, which says triangle ABC has those coordinates, and they want us to prove that this triangle is an isosceles triangle. So if I follow the steps for developing my coordinate proof, the first thing I'm going to do is go ahead and draw and label my graph. And once I plot my points, I'm going to dig out my straight edge and use my straight edge to go ahead and draw that triangle. Step number 2 says state the formulas that you'll be using. Well, at this point, I really don't know what formulas I'll be using till I think a little bit more deeply about this problem. In this question, they're asking us to prove that this triangle is isosceles. Well, in order to prove it's isosceles, I need to know what an isosceles triangle is. So again, if we dig back to those middle school years and think about the way we classify triangles, I'm going to ask you to think about what makes an isosceles triangle an isosceles triangle. Hopefully you're remembering that an isosceles triangle is a triangle that has at least 2 congruent sides. So in other words, my goal or my mission now is to prove, using slope, distance, or midpoint, that this triangle has 2 sides of equal length, or 2 congruent sides. Well, like scalene, the formula that's going to help me do this is the distance formula. If I can show that the length of any 2 sides are exactly the same, that's going to make my triangle an isosceles triangle. Since distance formula is the one that I'm going to be using for this problem, the very first thing I'm going to do is write the distance formula on my paper. And at this point, I need to go figure out or use my diagram to figure out which 2 pieces I want to find my lengths for. I can certainly, by all means, find the length of all 3 sides. Once I knew the length of all 3 sides, I could show that any two of them were the same. But if I'm a little clever, a little smart about how I do this, I might end up with just a little bit less work to do. So in looking at the picture, I'm thinking that probably side BC and side AB are going to be my two congruent sides. So those are going to be the first two that I'm going to go find lengths for. If they come out the same, then I'm done. If they don't come out the same, then I'll go ahead and find the length of AC. All right. So the length of line segment AB is going to be the same as the distance between points A and B. So distance between points A and B is going to be equal to the square root of 7 subtract 2 squared plus -1 subtract a -2 squared. Now remember, when you enter distance formula into your calculator, you're going to enter everything that's underneath the square root sign exactly as you see it, starting with the open parentheses. So go ahead, take a minute, dig out your calculator. While you're doing that, I'm going to dig mine out, and I'm going to enter that into my calculator exactly as I see it. So I'll go open up a new document. If it asks, you don't want to save the current one, but I'm going to enter that exactly as I saw it, beginning with the open parentheses. So I want to do 7 subtract 2, and I want to square it. To that, I want to add a -1 subtract a -2 squared. You should be entering this on your calculator at home just the same as I'm entering it on my calculator here. And it tells me when I enter all that, that's equal to 26. So what I have underneath the square root sign in this particular case is 26. So my distance between points A and B, or in other words, the length of line segment AB, is going to be equal to the square root of 26. That square root doesn't have any factors that are perfect squares, so I don't have to simplify it. I am all set and can go on and find now the length or the distance between points B and C. So the distance between points B and C is going to be 2 subtract 3, square it, plus -2 subtract 3 squared. And again, you need to dig out your calculator and perform these computations the same as I'm doing them here in the video. And just like I did in the first example, I'm going to enter everything underneath the square root sign, but not the square root itself. So I'll start with that open parentheses and do 2 subtract 3, square it, plus, and then a second set of parentheses, -2 subtract 3, square that. And this one too, it tells me that my answer is the square root of 26. So the distance between points B and C, square root of 26. So now I've got one line segment, or one side, whose length is square root of 26. I've got a second side whose length is square root of 26. Since I have two sides of equal measure, I know now that I have two congruent sides, forcing my triangle to be an isosceles triangle. All right, so what I've proven here is I've shown that triangle ABC is an isosceles triangle. And now I have to state the reason why. Since I have shown it has two sides of equal measure. And I'm going to say two congruent sides. Done. If you have questions about what I did with this proof, please jot these down in the margin too, and that way you can remember to ask, and I'll answer them the next time you come back to class. All right, last thing, just to wrap this up. How could we use our knowledge of coordinate geometry in order to prove that a triangle is equilateral? Well, in order to prove that it's equilateral, you have to know what an equilateral triangle is. Hopefully you know it's a triangle with 3 congruent sides. And then the question you need to ask yourself is, which formula, slope, midpoint, or distance, would you use to show that a triangle has 3 congruent sides? And just like with the first two, we're going to use the distance formula. And I would say use the distance formula to show that all 3 sides are congruent. Hopefully you have a pretty good handle on what formulas you would use and how come, because the next time you come back to class, we're going to go ahead and use our knowledge of proof and our knowledge of coordinate geometry in order to write some more of these coordinate geometry proofs.